With every breakthrough in chip design, Apple reaffirms its dedication to redefining the limits of technology. From iPhones to MacBooks, Apple's custom chips don't just raise the bar for performance and efficiency, they're steering the entire future of computing. Apple's venture into chip design has been marked by groundbreaking advancements and technological leaps. It all began with a bold move in 2008, when Apple bought the processor company PA Semi for $278 million. CEO Steve Jobs claimed the PA Semi would develop system-on-chips for Apple's iPods and iPhones. Following the acquisition, Apple signed a rare architecture license with ARM, allowing the company to design its own core using the ARM instruction set. The first Apple-designed chip was the A4, released in 2010. Powering the iPad and the iPhone 4. The A4 integrated the CPU, GPU, and RAM into a single chip, delivering unprecedented efficiency and performance. The subsequent A5 chip in 2011 brought dual-core architecture to the forefront, doubling the processing power and elevating graphics capabilities essential for the iPad 2 and the iPhone 4S. By 2013, Apple introduced the A7 chip, a game-changer in mobile processing with its revolutionary 64-bit architecture. This breakthrough not only boosted speed and efficiency, but also set a new benchmark in the industry, pivotal for devices like the iPhone 5S and iPad Air. Building on this momentum, the A9 chip in 2015 integrated the M9 Motion coprocessor, enabling always-on Hey Siri functionality and further enhancing overall performance. In 2017, the A11 Bionic chip ushered in a new era with its neural engine designed to handle AI tasks with finesse. This innovation played a crucial role in advancing Face ID and Animoji features on the iPhone X, underscoring Apple's commitment to integrating cutting-edge AI capabilities into its devices. Fast forward to 2020, Apple made waves in the computing world with its transition to Apple Silicon. The M1 chip marked a monumental shift for Macs, leveraging ARM-based architecture to deliver unparalleled performance and efficiency. In November 2020, Apple released the first Macs with the ARM-based M1 chip, debuting the 13-inch MacBook Pro, MacBook Air, and Mac Mini models. In early 2021, Apple added the M1 iMac and the M1 iPad Pro. The M1 was the first Apple-designed system on a chip, or SoC, developed for use in Macs. It marked Apple's first step toward transitioning away from the Intel chips that the Cupertino company had used in Macs since 2006. A major factor built into the M1 chip is the unified memory architecture, which lets the CPU, GPU, and other processor components access the same data pool without needing to copy data between one another. This brings notable speed and efficiency improvements to the M1. This memory architecture means that the RAM is not user upgradable, which isn't surprising because few Macs have user-accessible RAM. M1 Macs max out at 16 GB of RAM, but even the base 8 GB is enough for everyday tasks. There are 16 billion transistors on the M1, the most Apple has ever put into a chip, making it the fastest CPU core available in lower power silicon and providing unparalleled CPU performance per watt when it was released. Apple's chip design allowed it to create Macs that were faster and more powerful and efficient than was possible with Intel-designed chips. Unlike Intel chips built on the x86 architecture, the Apple Silicon M1 uses an ARM-based architecture, much like the A-series chips that Apple had been designing for iPhones and iPads for years. The M1 chip was the most powerful chip that Apple had created to date when it was released, similar to the A14 chip in the latest iPhone and iPad Air models at the time. Built on a 5nm process by Taiwan Semiconductor Manufacturing Company, or TSMC. TSMC builds all of Apple's chips and has done so for many years. At the time, Apple released the 2020 MacBook Air, 13-inch MacBook Pro, and the Mac Mini with the M1 chips, replacing the low-end machines in those lineups. Apple also introduced the M1 versions of the iMac and the iPad Pro. The M1 chip includes an 8-core CPU with 4 high-performance cores and 4 high-efficiency cores. The high-performance cores are designed to offer the best performance for power-intensive single-threaded tasks. The 4 high-performance cores can work together to offer impressive multi-threaded performance that has allowed the M1 Max to outshine even the highest-end 16-inch MacBook Pro models of the time. While the number of efficiency and performance cores has changed over the years, Apple still employs this same method with their current M3 and M4 processors. For tasks that are less intensive and don't require the same power, such as web browsing, there are other high-efficiency cores that use a tenth of the power to preserve battery life. Apple says these cores offer performance similar to the prior generation dual-core MacBook Air, but at much lower power. These cores can work alone when significant power isn't needed, but for demanding tasks, all 8 cores can be engaged at one time. The first Apple Silicon M1 chip had 8-core GPU, but there's also a version used in the entry-level MacBook Air models that has one of the cores disabled for a 7-core GPU. GPUs in the Mac Mini, MacBook Pro, and higher-end M1 MacBook Air models were all 8-core GPUs, capable of running close to 25,000 threads simultaneously, and with 2.6 teraflops of throughput. According to Apple, the M1 was the fastest integrated graphics in a personal computer at the time. The M1 chip also built in a neural engine, which is still in current chips, a component that Apple first started adding to its A-series chips a few years before. The neural engine is designed to accelerate machine learning tasks across the Mac for things like video analysis, voice recognition, image processing, and more. The neural engine is capable of 11 trillion operations per second, providing up to 15 times faster machine learning performance compared to the previous generation of models that were moved to the M1. And this number only improved with later M-series processors. The M1 chip brought 3.5 times faster CPU performance and up to 6 times faster GPU performance and 15 times faster machine learning capabilities compared to the Intel chips used in prior generation machines. And at the time, compared to the other PC laptops that were releasing, the M1 offered 2 times faster CPU performance and did so using just 25% of the power. Even with all the incredible speed improvements that the M1 chip brought, it's also more battery efficient than any other Mac chip Apple had released to date. Battery life in an M1 Mac lasts up to 2 times longer than in prior generation Macs. The Mac with the longest battery life was the 13-inch MacBook Pro, which lasted for 20 hours. Because the M1 chip used different architecture, Apple had built tools to allow developers to create universal app binaries that run flawlessly on both Apple Silicon and Intel chips. Additionally, it has developed the Rosetta 2 translation layer that allows x86 apps to run on the M1 chip, and of course the current M processors. Rosetta 2 is a reimagining of Rosetta, the feature that allowed PowerPC apps to run on Intel-based Macs back in 2006 when Apple swapped to Intel from PowerPC. With Rosetta 2, apps designed for Intel machines will continue to run on the current M Macs with some limited performance compromises. Apple in June of 2022 introduced the M2 chip in the updated MacBook Air and 13-inch MacBook Pro models. The M2 featured the same 8-core CPU as the M1 but offered GPU cores with 9 and 10-core GPU options, up from the 7 and 8-core options in the original M1 chip. The M1 chip-powered MacBook Air and the MacBook Pro received an overwhelming response from consumers. As of 2023, Apple had a global PC market share of 21.3%. A decade ago, it was just 12.8%. Since the launch of Apple Silicon, Apple saw growth of a whopping 60%, while Windows growth stood at just 6%. The M1 chip also powers part of Apple's iPad lineup, making them as good as any other laptop on the market. With the release of newer M2 and M3 chips, Apple is on the cusp of dominating the premium PC industry. If you enjoyed this video, like and subscribe for more updates on transformative innovations.